So we're going to take a look at histograms, and we've talked about this before already. We're going to get to a little more into the details. But again, the idea is that a picture is worth 1,000 words. So we could be given a whole bunch of data and say it's reams of data. It's like, okay, how do you make sense of this? So maybe we can use a frequency table. That might help. But then if we really want to take a look at what this data is doing, we could use a histogram. So let's use the McDonald's example. This is those wait times. So I'll bring back that chart. And so the frequencies were 11, 24, 10, 3, and 2. Now, we could put these as relative frequencies if we wanted to. As relative frequencies, that means these would be percents. So the total that we have is 50. So 11 over 50, or 11 out of 50 is 22%. And then let's see here, 24 out of 50. And then 10 out of 50. 6%. And 4%. So there we go. So again, if you want to find the percent, take the frequency, divide by the total, you'll get some decimal number, multiply by 100%. And that gives you these numbers. So we have our frequencies, we have our relative frequencies. So we're going to put this on a histogram. Now, the first thing with the histogram is we're going to use class boundaries. What I had here on the left, the times, those were classes, and we went over how to put this kind of thing together. So what we're going to look at now, this is where those class boundaries are going to become important. We're going to put that together. So as we construct this, I'll get my original data here. There it is. So we're going to have a horizontal axis, and this will be for our times. And what we're going to do for the first class, instead of going 75 to 124, we're going to use the class boundaries. So 74.5 to 124.5. And then we're just going to go on from there. 174.5 to 24.5 to 74.5 and 324.5. And then we're going to have our frequencies. So I'll say 5, 10, 15, 20, 25. All right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So again, we're going to use class boundaries for the width of these bars. So for the first one, frequency was 11. So we can do something like this. Next one, 24. Next one, 10. then 3, roughly like that. Let's see, am I missing one? 10, 3, and then 2. There we go. So there's our histogram. And again, we can kind of see what's going on. It's like there it is. There's a picture of what the data is doing. Now, what we could do, we could also set this up, just like we have a frequency table. We have a relative frequency table, and we saw those relative frequencies. And so what we could do, we could do this relatively. We don't have to just use, say, the actual frequencies. We can change this up a bit. So this would be a histogram using frequencies. Here, I'm going to use relative frequencies. And the key thing with the relative frequency histogram, kind of look the same as the other histogram. So let's see. This is going to be a little tricky here. So this turned out to be 48%. So I'm going to put 50% up here. Let's see, this one, 22. So let's say this is 25%. So that would put this one at 22. That's a 25 there. I know it's hard to see. Next one, let's see, 20%. Ooh, let's see. Oh, this one should have been a little lower, I think. Pardon me on that. That'd be 20%. Yeah, I should have driven this one a little bit lower. And then 6%. So let's say this would be 10. That's going to be, again, not quite. Let me do this one again. I'm going to start this over because it's a little easier to do the percents and then adjust and have the bars. But the key thing actually, other than artistic license on my part or artistic foolery on my part, you're going to get the exact same distribution. But it's easier to construct this other way. So let me just start over. A little more room. Say this is 25, and then 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And let's see here. So we have, going back, looking at those frequency, relative frequencies, those percents. First one's 22%. So it's going to put it not quite halfway. And there we go. So that's the first class. Second class, 48%. So almost a 50, just short. Okay, sort of like that. So this would be 48%. 20%. A little lower. I had trouble with this one before. You just make this one a little bit lower than this one. That's about right. Maybe even a little lower. Yeah, that's better. And then 6%. And then finally 4%. There we go. Again, the idea is that the graphs look the same. They have the same kind of distribution. And as again, aside from my artistic license, they're actually the same graph. It's just instead of having frequencies, we now have percents. And we only needed to go up to 50%. The largest percent we had was 48. We didn't need to go all the way to 100, but we could have if we wanted to. So you have your histogram based on frequency, your histogram based on relative frequency or percent. And again, we're using the class boundaries to start and stop the base of these bars. So sort of an intro there, a little bit of histograms. Now we're going to take a look at some things that are good about these. So things that are good, well, you get a distribution of data, and it's visual. It's not just the data in a chart. It's not just listed out as raw data. We get, again, a picture is worth 1,000 words. We can see what the data is doing to some extent. Also, it gives the location of a center. And we could think of a center as, in a way you can think of it as like a peak. Now, not all data distributions just have this one peak. You'll get data distributions that have 2 peaks. But in this case, we have one. And this lets us see that's a property of our data. We refer to this as a center. Now, it also shows the spread of our data. It shows the spread of our data. And that's just, how wide is it distributed? In our case, we had data classes with boundary starting at 74.5. That's the lowest boundary, and the highest boundary was 324.5. And okay, so we're going from sort of the mid 70s to low-ish 300s. But we might have data spread out from, say, 0 to 1,000. But it gives us an idea of what the spread of our data is. Are we dealing with very narrow figures, like we're dealing with, say, 70 to 72, and all the data is packed in there? Or again, it's spread out 0 to 1,000. So it gives us an idea of how spread out or not spread out our data is. Finally, you can use it to identify outliers. Now, outliers are pieces of data just kind of way out there. We have this center of data where the data seems to be sort of gathering, and that might be the peak of our data. I mean, that's what we're looking at here in the histogram. So in this case, an outlier is going to be kind of far removed from that, and we'll be able to see those. So these are advantages of histograms. Now, there is some properties, or there are some properties for histograms. First off, we're going to talk about the normal distribution. And the normal distribution is something that starts out like this. We're going to increase from low frequencies or small frequencies. And then we're going to reach, again, some kind of a peak or a center for our data. So we're going to have some, say, one or a few, maybe one or two. So we'll get something like this. And then we're going to start decreasing again. We're going to decrease the small frequencies again. And what this looks like, do we see like a histogram kind of like this? Now, when we talk about something having a normal distribution, we're talking about an approximation. It's not going to be a perfect fit. It's going to be good enough. And what you typically get is approximately something that we call a bell curve. But we'll call this approximately normal for now. Now, there are other distributions that have kind of a bell curve to them, for example, t-distributions. But the sort of the classic bell curve is your normal distribution. And again, it's not going to fit, but if it's good enough, well, then we'll be happy with it. So that's the normal distribution. The other kind we're going to take a look at here today is the uniform distribution. I'm going to abbreviate distribution. But what this one looks like, the bars in your histogram or histogram, they're going to be roughly, very roughly the same height. So you're going to get something kind of like this. So it's kind of the same height, but again, it just has to be good enough. You can kind of see there's a trend here. Now, some other properties of histograms. So we've seen the normal histogram, approximately normal, the uniform histogram, and again, there's other kinds of distributions. There are other kinds of distributions out there, like you can have like beta distributions and gamma distributions, chi-square distributions. So it's not just these sort of bell-shaped curve or just uniform. But there are some properties of this bell-shaped curve that we do want to look at. We call this skewness. And first one we'll look at is skewed to the right. When a histogram is skewed to the right. So we have our histogram here. And what it's going to look like is to the right, we're going to have some more values, more on the right than we do on the left. And so what this is a shape kind of like that. So that's what we mean by skewed to the right. Now it's skewed to the left. Well, this would be skewed to the left. So again, we kind of have a peak here, but the peak's not in the center. So we have this sort of tail that goes to the left of our distribution. All right. So that's really it for histograms. So again, now this is used for numerical data. Oh dear, I got a bar in here. Woo. Some spelling here. There we go. So this is an introduction to histogram, and I should just make this note, and I probably should have made this in the beginning. This is for numerical data. Now, there's another kind of graph that looks like a histogram that uses categorical data. And we're going to get to that, and that's called a bar graph, but we'll talk about that later. But that's your histograms, your introduction. If you have any questions, let me know.